Hello and welcome to this video. The topics about graphs we discussed in the last videos are called statistical analysis. In contrast to that, we're going to talk about descriptive statistics, which provides us yet another way to present data distributions. The topic includes many contents, but we are going to focus on the measures in the distribution first. In the next 3 videos, we will learn to measure the center, spread, and position. So stay tuned. Let's start with measuring the center. Average. I'm sure you hear this word very commonly in your daily life. Average score, average cost, average age, and so on and so forth. But have you ever stopped and thought about what exactly is average? In fact, there are various ways to define the average of a set of data, and we unconsciously use the most suitable one under different circumstances. However, being aware of the definitions can help us reduce misunderstanding and avoid being misled by some information. 2 primary ways of denoting an average are the mean and the median. The mean, or more accurately, the arithmetic mean, is mathematically defined as sigma x over n, where sigma x represents the sum of all the elements in the dataset we are considering, and n is the number of elements in that set. For example, we can find the mean here by adding up the number of apples in all baskets, and then dividing the sum by the number of baskets. This is easy because the complete set of items of our interest is known. The mean we calculated here is called the mean of the whole population. We denote it by the Greek letter mu. However, in real life it is very hard or even impossible to get information on the whole population. Therefore, we sometimes estimate a population mean from a sample mean. The word sample often implies a simple random sample, which is a part of the population selected in such a way that every possible sample of the desired size has an equal chance of being included. We will talk more about this in the future. The mean of a sample is denoted by x bar. The median is the middle number of a set of numbers arranged numerically in either ascending or descending order. With an odd number of elements, the median is exactly in the middle. In this example, we first arrange the numbers from the smallest to the biggest. Then we can easily see that 5 is the median because there is an equal number of elements in each side. However, in the second example, the numbers of baskets is an even number, so we are left with 2 middle numbers. To determine the median, we take the arithmetic mean of these 2 numbers. Thus, the median is 4 plus 6, then divided by 2, which gives 5. Now, here's the set of data, and let's first calculate its mean and median. We add the numbers up and divide the sum by 7 to find the arithmetic mean, which is 5. Then we order them, and 6 turns out to be the median. Since both mean and median can be used to describe the center of a distribution, it makes sense that they are quite close to each other. But what if instead of 8 we have a much larger number, say 50? Obviously, it will affect our measures of the center, so let's do the calculations again after replacing 8 with 50. The mean then becomes 11, which is quite a big change. Yet the median didn't change at all. This shows the median is resistant to extreme values. That is, extreme values and outliers don't affect the median much, while they hugely impact the mean. Another interesting thing to think about is how will the mean and the median change if we add the same constant to every single element in the set. If we add 3 to every number, then the mean and the median will be raised by 3 too. Same goes with multiplication. If we multiply everything by 2, the mean and the median will increase by 2 as well. Recapping, today we talked about measuring the center in distributions. We introduced mean and median and discussed some interesting characteristics of mean and median. And that's all for today's video. See you soon!